Lockout tagout procedures are crucial for ensuring safety when working on your electrical equipment like motor control centers. These procedures, often abbreviated as LOTO, prevent accidental energization of equipment during maintenance or repair, protecting workers from electrical hazards. Several online resources offer valuable information and templates for creating lockout tagout procedures. The Occupational Safety and Health Administration, or OSHA, provides comprehensive information on lockout tagout standards and best practices. Their website offers guidance on developing and implementing effective LOTO programs. The National Electrical Contractors Association, or NECA, also offers resources for electrical safety, including lockout tagout procedures. Their website may provide industry-specific recommendations. The Electrical Safety Foundation International, or ESFI, is another valuable resource for electrical safety information. Their website includes resources on lockout tagout and other electrical safety topics. When developing lockout tagout procedures for an MCC center, consider using printable documents to ensure consistency and clarity. A lockout tagout policy and procedure document should outline the purpose, responsibilities, steps, and documentation requirements of the program. This document should clearly define who is authorized to perform lockout tagout, the steps involved in isolating energy sources, and the procedures for verifying that the equipment is de-energized. An energy isolation checklist helps ensure that all energy sources are identified and isolated before lockout tagout is performed. This checklist should include all potential energy sources, such as electrical, mechanical, hydraulic, and pneumatic. It should also include steps for verifying that each energy source is effectively isolated. A lockout tagout permit authorizes the lockout tagout and ensures that equipment is not energized without proper authorization. This permit should include the date and time of the lockout tagout, the equipment being locked out, the names of the authorized personnel, and the steps taken to isolate energy sources. Tagout devices such as tags, locks, and barriers are used to physically isolate energy sources and prevent accidental energization. These devices should be durable, clearly labeled, and easily identifiable. They should also be resistant to tampering and removal. When implementing lockout tagout procedures, it is important to consider several key points. Firstly, ensure that the lockout tagout procedures are specific to the MCC center where they will be implemented. Each MCC center may have unique energy sources and configurations, so the procedure should be tailored accordingly. Secondly, train all employees who will be involved in lockout tagout procedures. Training should cover the purpose of lockout tagout, the steps involved in the process, the hazards associated with energized equipment, and the proper use of lockout tagout devices. Thirdly, regularly review and update the procedures to ensure their effectiveness. Lockout tagout procedures should be reviewed periodically to ensure that they reflect current equipment configurations, industry best practices, and regulatory requirements. Finally, keep a record of all lockout tagout operations for inspection purposes. These records should include the date and time of the lockout tagout, the equipment being locked out, the names of the authorized personnel, and the steps taken to isolate energy sources. Remember, it is crucial to consult with the inspector to ensure that the procedures provided meet their specific requirements. Regulations and standards can vary, so it's best to verify that the procedures align with expectations. The information available from OSHA directly related to lockout tagout or control of hazardous energy can be found in Title 29 Code of Federal Regulations, or CFR, Part 1910.147. This standard covers the servicing and maintenance of machines and equipment in which the unexpected energization or startup of the machines or equipment, or release of stored energy could cause injury to employees. The standard establishes minimum performance requirements for the control of such hazardous energy. Compliance with this standard prevents an estimated 120 fatalities and 28,000 injuries each year. The standard outlines several key elements for an effective lockout tagout program. These elements include developing a written energy control program, using lockout devices for equipment that can be locked out, using tagout devices when equipment cannot be locked out, implementing energy control procedures, training employees, and inspecting the energy control procedure periodically. The written energy control program should clearly outline the scope, purpose, authorization, rules, and techniques to be used for the control of hazardous energy. It should also include the means to enforce compliance, including consequences for violating the program. Lockout devices should be used whenever possible to physically prevent the equipment from being energized. These devices should be durable, standardized, and easily identifiable. They should also be designed to prevent accidental removal. Tagout devices may be used where equipment cannot be locked out. However, tagout provides less protection than lockout. Tagout devices should be securely attached to the energy isolating devices and should clearly warn against energizing the equipment. Energy control procedures should be developed for each piece of equipment that requires lockout tagout. These procedures should clearly identify the steps required to isolate the energy source, apply the lockout or tagout device, and verify that the equipment is de-energized. Employees who perform lockout tagout must be trained in the energy control procedures and the hazards associated with the equipment. Training should include the purpose and function of the energy control program, the steps required to isolate energy sources, the proper use of lockout and tagout devices, and the importance of following the procedures. The energy control procedure should be inspected at least annually to ensure that it is effective and that employees are following the procedures correctly. The inspection should be conducted by an authorized employee who is not involved in the energy control procedure. The OSHA standard also includes specific requirements for different types of energy sources, such as electrical, mechanical, hydraulic, pneumatic, and thermal energy. For electrical energy, the standard requires that the equipment be de-energized and that the energy isolating device be locked out. For mechanical energy, the standard requires that the equipment be brought to a zero energy state and that the energy isolating device be locked out. For hydraulic and pneumatic energy, the standard requires that the pressure be relieved and that the energy isolating device be locked out. For thermal energy, the standard requires that the equipment be cooled down and that the energy isolating device be locked out. In addition to the OSHA standard, there may be other state and local regulations that apply to lockout tagout. It is important to be aware of these regulations and to ensure that the lockout tagout program complies with all applicable requirements. When working on electrical equipment, it is crucial to follow safe work practices to prevent electrical shock and other injuries. These practices include wearing appropriate personal protective equipment, using insulated tools, and verifying that the equipment is de-energized before starting work. Personal protective equipment, or PPE, such as gloves, safety glasses, and hearing protection, should be used whenever there is a potential for exposure to hazards. Insulated tools should be used when working on or near energized electrical equipment. Before starting work on electrical equipment, it is essential to verify that the equipment is energized. This can be done using a voltage tester to ensure that there is no voltage present. If voltage is present, the equipment should not be worked on until it has been de-energized and locked out. Electrical hazards can be deadly. By following safe work practices and implementing effective lockout tagout procedures, employers can protect their employees from these hazards. Remember to consult with qualified safety professionals or electrical engineers for specific guidance on implementing lockout tagout procedures in your workplace. They can help you assess the risks, develop appropriate procedures, and train your employees. In addition to the resources mentioned earlier, it's worth noting that some insurance companies and safety organizations offer templates and guidance on lockout tagout procedures. Check with your insurance provider or industry-specific safety groups for additional resources. Proper lockout tagout procedures are essential for maintaining a safe working environment when dealing with electrical equipment and machinery. They protect employees from potential hazards associated with unexpected energization or release of stored energy. Always prioritize safety and follow established procedures to prevent accidents and injuries. The NEC, or National Electrical Code, provides guidance on electrical safety in the workplace, although it doesn't specifically outline lockout tagout procedures. However, the NEC emphasizes the importance of energizing equipment before working on it and provides requirements for disconnecting means and overcurrent protection. These requirements indirectly support lockout tagout practices by ensuring that electrical equipment can be safely isolated from its power source. For example, NEC Section 110.25 discusses the requirements for identifying and labeling disconnecting means for electrical equipment. This is important for lockout tagout because it helps workers quickly and easily identify the correct disconnect switch to energize the equipment. NEC Section 430.102 provides requirements for disconnecting means for motors. This section requires that a disconnecting means be provided for each motor and that it be located within sight from the motor. This makes it easier for workers to de-energize the motor before performing maintenance or repairs. NEC Section 70E, Standard for Electrical Safety in the Workplace, published by the NFPA, or National Fire Protection Association, is specifically dedicated to electrical safety requirements for employees working on or near energized electrical equipment. While not strictly the NEC, NFPA 70E is closely related and is often referenced in conjunction with the NEC. NFPA 70E provides detailed guidance on lockout tagout procedures, including the steps for de-energizing equipment, verifying the absence of voltage, and applying lockout tagout devices. It also covers requirements for training, personal protective equipment, and safe work practices. The standard emphasizes a hierarchy of controls for electrical hazards, with de-energizing equipment being the preferred method. Lockout tagout is a critical component of this de-energizing process. In summary, while the NEC itself doesn't explicitly detail lockout tagout procedures, it provides the foundation for safe electrical work practices by emphasizing the importance of de-energizing equipment and providing requirements for disconnecting means and overcurrent protection. NFPA 70E complements the NEC by providing detailed guidance on lockout tagout procedures and other electrical safety requirements for the workplace. Always consult both the NEC and NFPA 70E, along with OSHA regulations, to ensure compliance with all applicable electrical safety standards. Motor control centers, or MCCs, are common in industrial and commercial facilities. These centers house motor starters, circuit breakers, and other control equipment for electric motors. Due to the complexity of MCC, lockout tagout procedures are particularly important when working on them. Before performing any maintenance or repairs on an MCC, it is essential to de-energize the entire unit. This involves opening the main disconnect switch and verifying that there is no voltage present. Each individual motor starter or circuit breaker within the MCC should also be locked out and tied out. This prevents accidental energization of individual motors or circuits. When working on MCC, it is important to be aware of the potential for stored energy. Capacitors, for example, can store electrical energy even after the power has been turned off. These capacitors should be discharged before any work is performed. Mechanical energy can also be stored in springs or other mechanisms within the MCC. These mechanisms should be properly restrained before any work is performed. Hydraulic and pneumatic systems within the MCC can also store energy. These systems should be relieved of pressure before any work is performed. Thermal energy can also be a hazard, especially if the MCC has been in operation recently. Allow the MCC to cool down before performing any work. In addition to following lockout tagout procedures, it is important to wear appropriate personal protective equipment when working on MCC. This includes safety glasses, gloves, and appropriate footwear. When working on or near energized electrical equipment, use insulated tools to prevent electrical shock. Never work alone on electrical equipment. Always have another qualified person present who can provide assistance in case of an emergency. If you are not qualified to work on electrical equipment, do not attempt to do so. Call a qualified electrician. Remember that safety is always the top priority when working on electrical equipment. By following safe work practices and implementing effective lockout tagout procedures, you can protect yourself and others from electrical hazards. Lockout tagout procedures are designed to prevent accidents caused by the unexpected startup or release of stored energy from equipment. These procedures typically involve several steps. Firstly, identify all energy sources that could potentially energize the equipment. This includes electrical, mechanical, hydraulic, pneumatic, thermal, and other forms of energy. Secondly, notify all affected employees that the equipment will be de-energized and locked out. This ensures that everyone is aware of the lockout and understands the importance of not attempting to energize the equipment. Thirdly, shut down the equipment using normal operating procedures. This minimizes the risk of damage to the equipment during the lockout process. Fourthly, isolate the equipment from all energy sources. This typically involves disconnecting electrical power, closing valves, and blocking moving parts. Fifthly, apply lockout tagout devices to the energy isolating devices. These devices prevent the energy isolating devices from being accidentally re-energized. Sixthly, verify that the equipment is de-energized. This can be done using a voltage tester or other appropriate testing equipment. Seventhly, perform the necessary maintenance or repairs on the equipment. Eighthly, remove the lockout tagout devices only after the maintenance or repairs are complete and the equipment is ready to be re-energized. Ninthly, notify all affected employees that the equipment is about to be re-energized. Tenthly, re-energize the equipment using normal operating procedures. Finally, verify that the equipment is operating properly. Lockout tagout procedures should be specific to the equipment being locked out. Generic procedures may not be adequate to protect employees from all hazards. The procedure should be developed by qualified personnel who are familiar with the equipment and the potential hazards. Lockout tagout training should be provided to all employees who are involved in the lockout tagout process. The training should cover the purpose of lockout tagout, the steps involved in the process, the hazards associated with energized equipment, and the proper use of lockout tagout devices. Lockout tagout procedures should be reviewed and updated periodically to ensure that they are effective and that they reflect current equipment configurations and industry best practices. Lockout tagout programs should be audited regularly to ensure that they are being implemented correctly and that they are effective in preventing accidents. Lockout tagout is a critical safety procedure that can prevent serious injuries and fatalities. By following safe work practices and implementing effective lockout tagout procedures, employers can protect their employees from the hazards associated with energized equipment. Consider a scenario involving an MCC in a manufacturing plant. A maintenance technician needs to replace a faulty motor starter in the MCC. Before starting the work, the technician follows these lockout tagout steps. The technician identifies all potential energy sources for the motor starter. This includes the incoming electrical power, any control circuits, and any stored energy in capacitors. The technician notifies all affected employees, including the machine operator and other maintenance personnel, that the motor starter will be de-energized and locked out. The technician shuts down the motor using the normal operating procedure. The technician disconnects the incoming electrical power to the motor starter by opening the circuit breaker and locking it out. The technician verifies that the motor starter is de-energized by using a voltage tester to check for voltage at the starter terminals. The technician applies a lockout tagout device to the circuit breaker, preventing it from being accidentally re-energized. The technician proceeds to replace the faulty motor starter. After the replacement is complete, the technician removes the lockout tagout device from the circuit breaker. The technician notifies all affected employees that the motor starter is about to be re-energized. The technician re-energizes the motor starter by closing the circuit breaker. The technician verifies that the motor is operating properly. By following these lockout tagout steps, the technician ensures that the motor starter is safely de-energized during the maintenance work, preventing any potential electrical hazards. This scenario highlights the importance of having detailed and equipment-specific lockout tagout procedures to minimize risks and ensure a safe working environment. The principles of lockout tagout extend beyond just electrical systems. Any equipment that can cause harm due to unexpected startup or release of stored energy requires a lockout tagout procedure. For example, hydraulic systems, pneumatic systems, and even gravity-fed systems can pose hazards if not properly controlled during maintenance or repair. A hydraulic press, for instance, stores a significant amount of energy in its hydraulic fluid. Before working on the press, the hydraulic pressure must be relieved and the system locked out to prevent accidental activation. Similarly, a pneumatic conveyor system stores compressed air that can cause injury if released unexpectedly. The air supply must be shut off and the system bled down before any maintenance is performed. Even a simple gravity-fed conveyor system can pose a hazard if not properly secured. The conveyor belt must be locked out to prevent it from moving while someone is working on it. The key is to identify all potential hazards associated with the equipment and to implement appropriate lockout tagout procedures to mitigate those hazards. This requires a thorough understanding of the equipment and its operation, as well as a commitment to safety.